Cities are growing faster than ever, and with that growth comes two major challenges: how to produce enough food and how to use energy sustainably. Urban farming sits at the intersection of these challenges, offering a powerful opportunity to rethink how food and energy systems work together. Urban farming refers to growing food within cities using rooftops, vertical farms, balconies, warehouses, and community spaces. When combined with smart energy use, it becomes a key solution for sustainable urban living. Traditional agriculture depends heavily on fossil fuels for machinery, fertilizers, transportation, and storage. Food often travels thousands of kilometers before reaching urban consumers, consuming large amounts of energy along the way. Urban farming shortens this distance dramatically. By producing food close to where people live, cities can reduce transportation energy, lower carbon emissions, and increase food freshness and security. Energy use is a critical factor in modern urban farming systems. Indoor farms, vertical farms, and greenhouses require electricity for lighting, climate control, water circulation, and automation. At first glance, this may seem energy intensive, but the efficiency of these systems is constantly improving. LED grow lights now use far less energy while delivering precise light wavelengths that maximize plant growth. Climate controlled environments reduce crop losses and allow year round production, making energy use more predictable and efficient. Renewable energy plays a central role in making urban farming sustainable. Solar panels installed on rooftops or greenhouse structures can power lighting and irrigation systems. Wind energy, where feasible, can supplement electricity needs. Some urban farms also use waste heat from nearby buildings or industries to warm greenhouses, turning excess energy into productive use. This integration transforms urban farming into part of a circular energy system rather than an isolated food production unit. Urban farming also contributes to energy efficiency at the city scale. Green roofs and rooftop farms act as natural insulation, reducing building heating and cooling demands. Vegetation absorbs sunlight and cools the surrounding air through evapotranspiration, lowering the urban heat island effect. As a result, buildings with urban farms often consume less energy overall, creating benefits beyond food production. Water and energy are closely linked in urban farming. Hydroponic and aquaponic systems use significantly less water than conventional agriculture, which also reduces the energy required for water pumping and treatment. Recirculating systems minimize waste and allow precise control over inputs. In some cities, treated wastewater is safely reused for irrigation, further reducing energy and resource demands. Technology and automation are accelerating the energy efficiency of urban farming. Sensors monitor temperature, humidity, light, and nutrient levels in real time, ensuring energy is used only when needed. Artificial intelligence and smart controls optimize lighting schedules and irrigation cycles, reducing waste while maintaining high productivity. These technologies allow urban farms to produce more food using less energy per unit of output. Despite its promise, urban farming faces challenges related to energy costs and infrastructure. Electricity prices, initial investment, and access to renewable energy can limit scalability. However, as renewable technologies become cheaper and cities invest in green infrastructure, these barriers are gradually decreasing. Policy support, energy efficient building codes, and incentives for renewable integration can further accelerate adoption. In the future, urban farming will be deeply connected to urban energy systems. Cities will produce food, recycle waste, generate renewable energy, and manage resources in integrated networks. Urban farms will not replace rural agriculture, but they will complement it by providing fresh produce, reducing energy use, and increasing resilience to climate and supply chain disruptions. Energy and urban farming together represent a shift towards smarter, more sustainable cities. By producing food locally and using energy efficiently, Urban farming helps cities move closer to environmental balance, food security, and climate resilience. As urban populations continue to grow, this integration will play an increasingly important role in shaping the future of sustainable living.